Welcome back all the participants. Today's session attendance sheet is posted in a WhatsApp group. Soon we will post the feedback link. From tomorrow onwards, for every session, we will post the attendance sheet. Respected Dr. Trilochan Panigrah sir. Good afternoon, sir.
Good afternoon. Am I audible?
Yes, sir, it is audible.
Okay.
Welcome to the FTP of Bio-Inspired Computing for Data Analytics, sir.
Thank you.
I request Dr. K. Anupriya madam to give a talk on resource person.
Thank you, Sherwani. It gives me great pleasure to introduce our resource person, Dr. Trilochan Panigrahi. Currently, he's working as an associate professor in the Department of ECE at NIT Goa. His research interests are distributed signal processing, array signal processing, IoT, and nano wireless sensor networks. Sir published more than 21 journal articles in well-reputed journals and more than 46 conference proceedings and 4 book chapters. Sir guided 2 research scholars in the area of wireless sensor networks and IoT. Sir got 500 projects from various funding agencies like DST and SIR. He also bagged so many awards and achievements like Best Paper Award at ICIT Conference in the year of 2009, Project Associate in UK IERI project, Visiting Research Scholar in UK University, next Institute Fellowship during PhD program at NIT Roorkela, MHRD Scholarship during his MTech. Sir also organized various workshops, STTPs, conferences and webinars. We are honored by your presence, sir. Thank you so much. Now I request sir to take over the session.
Thank you, madam, for your kind words to introduce me. Now, how can I share my presentation? Is there a process?
Yes, sir. So you're already the presenter. You can share your presentation, sir.
Okay.
Share content. Just beside the mic symbol, there is a thing called share content. If you click on that.
Okay.
Yes. Some photo is visible here.
Now my screen is visible.
Yes, sir. Someone else is presenting, sir. Just a minute. Sir, can you start sharing your screen, sir?
Sure. I think now it is visible.
Yes, sir. Yes, sir. It is visible, sir.
Okay. Hello, everyone.
Yes.
Thank you. Thank you, the organizers, for giving this opportunity to share some of my research experience. And thank you for your nice introduction. Friends, today I am going to talk the application of smart intelligent technique in wireless sensor network. We may learn different swarm intelligent technique like particles for optimization, bacteria foraging, a lot of intelligence algorithms we may learn or I'm going to learn them. I may not go in detail of about the algorithm, but how to use in different application, in particular in wireless sensor network will be discussed. The outlines of my today's talk is followed here. First, let me introduce what is WSN very briefly, what I think basically. Then the important task of a wireless sensor network parameter estimation, that too in the distributed scenario. Since you are deploying this sensor node in an unattended area, we have to collect the data and take a lot of decisions. Why we are going for distributed parameter estimation? That importance will be discussed. The two way of cooperation among the sensor nodes, known as incremental and diffusion, how they cooperate themselves and what is the difference between these two kind of cooperations also will be discussed. Then one of the example how the parameter estimations is that IR system parameter estimation. IR stands for infinite impulse response system. It is a feedback system. That too using the PSO diffusion scenario that will be discussed. This is one of the example. Then the second example, what people are doing, and I also did some work, that is application of the smart intelligence algorithm for source localization. It is one of the tasks in sensor network. When an event occurs, we should know, we localize where it is, where it occurs, and track the particular intruder also sometimes. So the different methods are followed, and at the end I'll conclude with some relevant references. So we know that wireless sensor network. Since the last decades, we are talking about this, but not sure when it started, right? If you look back in 1958, the IGLU operation, especially in Russia and America, these countries, they built very huge sensor nodes to check out the movement of different military equipment and military persons. The sensor nodes are very huge at that time, expensive also. With the advantage of IC technology, the digital technology, the MEMS technology, and advanced communication technology, we are able to make the sensor node very small, battery enabled. So gradually, there are a lot of applications, and we have seen this in habitat monitoring, precision agriculture, security in the military, automation in the industrial. And automation 4 is the industrial automation completely based on IoT, and we are deploying different kind of sensor there. This is one kind, macro scale sensor we have developed. Gradually, we are also moving to the nano sensor in the nano scale, especially in the different parameter in a plant and in human body, in the human body sensor network. If you look, we are developed nano sensor. Thanks to the material like graphene that can generate in terahertz frequency as well as receive the signal. That part is separate, but nano sensor network is the current research topics many people are doing throughout the world. Okay. So there are two scenarios if you talk about the sensor network. The first scenario is the macro WAN wireless sensor network. It's little large, so both way communication can be feasible. We can measure the environmental parameter, you can share with the user, and the user also can give certain instruction command what to do, what not to do to the different sensor nodes. So both way communication is feasible in the macro sensor, in the smart city applications and all the applications what we look the sensor nodes what we are having maybe in the laboratory, all are macro sensor. Think about the scenario to nano WAN. The billions of nanoparticles you can spread in a particular region, either in a nuclear plant or it's a thermal furnace or in a human body. If particular event occurs, then what will happen? They generate a kind of pulses. That pulse reach to a sink. We are using array of antenna, the graphene kind of materials used here. From the received signal, we can decide what kind of event had been occurred there. So this kind of sensor network, known as nano WAN, nano IoT is also buzzword people are using them. Okay. So two scenarios. So briefly, you can see this thing. Okay. If you come to the applications of WAN, many, and it is not limited to what I have shown here. The sensing the environment is one of the applications where we know this and we are doing this. As a project work, we also deployed a sensor network to monitor the noise level in a city, that and a different kind of air pollution in the real time also we measure using the sensor network and the concept of IoT. Second application, especially in the military, we are using these surveillance, the target localization tracking. Some more people have done, and still there are a lot of challenges. The collaborative beamforming, it is one of the important tasks in current communication standard and future millimeter wave communications. The channel estimation is one of the important tasks of any communication system. If you are going for a higher frequency, then the challenges are more. The channel impedance we don't know, we cannot predict, so estimation must be required. So this is one task also available. A spectrum sensing, it also people have been developed, a lot of things in radio. These are the applications where people are working on this. And even nanoscale, you want to detect a particular kind of virus or bacteria in human body or in a plant, we are spreading a lot of nanoparticles and can detect them. Some chemical reaction in a chemical reactor. In target delivery of drugs also feasible because of the nanoscale sensor network. It is used to detect the cancer cell. So we are lot applications not limited. Lot of applications and scopes are still there in wireless sensor network. But everywhere we cannot apply smart intelligence. But in these applications, people have used smart intelligence or machine learning approaches to improve its performance in different scenarios. I may not follow a lot in this current presentation. Now come to the topic what we are supposed to be discussed today. I said a sensor network, the sensor nodes like this are deployed in a particular region. There is a central processor. The central processor is supposed to collect the information from all the sensor nodes. So there are two approaches. One is each of the sensor node can send their information to this central processor. The centralized approach is very convenient also. So what is the disadvantage? If you look, each sensor node, when they want to transmit the data to this user, they cannot transmit directly to the base station. There is a multi-hop communications. One sensor transmits to its neighbor. Neighbor transmits its own data along with the data received from the others to next neighbors. Like this, it reaches to the central processor. It's a multi-hop kind of communications. So in this multi-hop communication, a lot of communication happens, and the communication consumes a lot of energy compared to the processing. That too, the sensor node which are nearer to the central processor, they need a lot of communication to communicate their own data along with the data in the edges. So there is this is not a uniformly distributed communication overload. So a lot of communication involved in this process. Once the central processor fails, means whole network will also fail. So how can improve this? These are battery powered. If your battery goes down, the sensor not under no use. So that is the problem. So improve the energy efficiency of a sensor network. We need these communications must be not required to centralize, should be shared themselves in the neighbor node and get some information, some processing can be done. So that kind of cooperation is required here. There are two types of distributed approach, means how they will cooperate themselves. That can be done. There are consensus method also available. This is the diffusion increment what we are going to discuss. We need to discuss how they will cooperate and how can minimize the number of communications among the sensor node. once you reduce the communication of rate, its energy efficiency increases. The sensor can work for longer time. Okay, that is the objective. Let us take an example so that we can understand the advantage of distributed estimation in wireless sensor network. Let us have a sensor network having small n number of nodes. They are uniformly distributed over a square meter area. And each node collects m measurements. For example, in a city, we deployed 100 sensor nodes to measure the temperature in the regular interval. So in the daytime, at 8 o'clock, we started recording the temperature till the evening. And I want to know what is the average temperature of all the nodes. Like this example, right? My objective is to measure the average temperature of all the nodes and measure a different instant of time. So n nodes and m number of measurement have been done. So the total number of data is n into m. We collect them, take the average. That is the objective. So there are three approaches are feasible. We can incorporate. So one of the approach is like centralized, no computation in sensor node, and directly what are the data they have measured, they have transmitted to the central processor. So in this process, what will happen? There are m number of data in each sensor node to transmit to sensor fusion center. So number of communication, how many data are m into n number of data? This many number of bits to be transmitted over the area of a distance of 1 meter. That is the one approach, centralized approach. The second approach, what I want to do, instead of transmitting the data of a sensor node to the central processor, I add some computational efficiency to the node. They can compute their own average. So instead of m number of data they are having, they compute their own average and they send the average of data instead of all the data. So what will happen in this process, if you add the computational capacity to a node, the number of communication, the data is reduced to order of n only, n number of nodes, that many number of average value to transmit it to the central processor, and it can be happen. But the distance of communication still not reduces. Some nodes may be far away. They have to also communicate to the central processor through multi-hop communications. So number of communication distance has been more, multi-hop communications have happened. Let's look here what I am doing. I've calculated the average at node 1 and share the average to the node 2. Node 2 update the average. So let's say the average is 5 and this average is 7. So 5 plus 7 by 2. So now this average becomes 6. They updated the average. Node 2, again, you'll send the information to node 3. Node 3 update the average. So in this way, once the cycle complete, at node 5, all the average will come and it will be a global average, right? So in this cycle, one node compute its own average, transmit the information to the next node, updated the average and transmit the next node. So at the end, we will have the average of all the nodes. Global average, you can achieve it, but without transmitting the data to the multi-hop communication like the central processor. So what happened? So in this process, the amount of communications has been sent because each node have to come from update and communicate to this node. But the problem is the multi-hop communication reduced. So that is the advantage, not problem. Sorry. So what so you see, this approach is known as the incremental cooperation among the sensor node. So in this approach, you are adding the computational capability of sensor node. At the same time, the communication not required to the central processor directly using multi-hop. We are using communicating with a neighbor only, one hop neighbor only. So amount of communication has been reduced further. So this approach is known as distributed. In this way also we can reduce the communications. You got it? All of you got it? What is the importance of distributed approach in wireless sensor network? You know, here basic objective to minimize amount of communication involved while computing a particular task, doing the particular task, and also trying to minimize the distance of communication, if you to reduce the multi-hop communication. So communication, you know, once a data want to communicate from other node, lot of things are involved. I'm not going to in that direction. You have to wait. So there are control channel, there are data channel, and sensor network. They are usually use ISM band. Number of data channels, control channels are very less. You have to wait long time to communicate data. So delay and energy both will be more if you want to communicate. Okay? So that is the thing I want to convey you. So when there is a network, distributed network, better go for cooperative communications, cooperative computations. Okay, friends. At the same time, if you look, you are unable to develop the mathematical equation for that. How can I use optimization technique today? Now I said I have to use my optimization technique or smart intelligence technique. It is optimization technique essentially. So you have to need to model all the things what you want to do mathematically. So you should write a cost function, and you have to minimize or maximize the cost function with respect to the parameter to be estimated. And at what point it's maximum or minimum, that right, the value, that location is known as the solution, and we know some idea about that. So when you are talking about a distributed process, so each of the sensor node, they have their own cost function, and the global cost function should be average over all the local cost function. Local nodes are there, and all the sensor nodes should have same objective. Here the objective is to find the average. And global objective also is the average of local objective. That should be formulated, first objective. Then come to what should be my local cost function. Let theta will be the parameter to be estimated, here the average value. So if you formulate how to get the average using this least square approach, means that theta, actual observation is x minus theta, that will be the error, and error square is the cost function. I have to minimize this error function. All right. So if there are m number of data at each node, and there are n number of sensor nodes, and total number of data is m into n, and this way I have to minimize this error, x minus theta square, error square. So this is a least square estimation problem. If you want to get what should be the local, you know, in the local each sensor node having m data, and this is the average error. So here it's clearly I can model my global cost function f of theta is the average of local cost function. So whatever may be problem you are working on this, either you're a student, PhD, or wherever may be working. So one, you know, that is my task, my work, so my objective. So you can formulate accordingly. Okay. So this is simplest example, finding the average. You can have different kind of algorithms. Okay. So now once we know what is my cost function, I can minimize using gradient method also. Simply differentiate this in that gradient method. So you can minimize, or you can use any smart intelligent technique to minimize this cost function. Okay. Now come to optimization technique. when you are talking about optimization technique, swarm intelligence techniques already there, no doubt at all. They are having certain advantage. The same time, certain disadvantage also with them because it can have a lot of computational complexity. They have to compute like anything. But LMS, this least mean square algorithm is the best optimization algorithm people has been used. It is a gradient-based algorithm. Very easy to do that also. So this is incremental method. I said before also, node 1 to node 2, node 2 to node 3 like this, it can happen. One node update its information using local observation and send that update information to next neighbor node. It will receive the previous node data and update using the local observation. So if you are little aware of this kind of algorithm, then you can better understand. So if you node by node was the previous node data, you get it. This is k minus 1 at a particular iteration. K is the node index. So previous node data you received. This is the present node data, input data. This is the desired data, what should be estimated. And you had the estimated data. And this is the error basically. So you use previous node data here, okay, as a past updated information. These are the some literature you can follow to get in detail about that. Incremental, one node to another node. Now, if you look the diffuse, what is the disadvantage in this method in incremental? Although it has very less number of communications involved in the computation, but you need a cycle. It covers all the node once. You know, if it is a very large network, difficult to. Sorry. Any questions? I'm not audible. Am I not audible? Okay. No. So this is a cycle required. That is the problem. You know? And once there is a particular node is, let's say, of sudden stop functioning, then you have to rebuild this cycle. The whole process will problem. See, to avoid that, to be more adaptive to the changes in the environment, we have used the diffusion kind of approach. What to do? A particular node receive information from all the neighbors instead of a single neighbor. It's receive the information from all the neighbors, diffuse them by following, the mathematical approach. That means you have to multiply a scaling parameter. The sum of the scaling parameters should be 1. If there are 3 nodes including 1, let's say double 1, double 2, double 3, double 4 are the weightage. The sum of the weightage should be equal to 1. So that should be followed. So diffuse one you can consider as the previous updated parameter and update using the present data like this 5. So if you look this equation, that equation here, 5 is the average of all the neighbor node is going to use in the updating equation. That's it. But it has communications are more because every node should be communicate with all the neighbors. Broadcasting kind of methodology can be used, but it is more adaptive to the real-time changes and more stable diffusion method. Now come to this, what I said, the example of IR system parameter estimation. If you want to estimate the parameter of infinite impulse response or feedback system, they are multimodal kind, since this smart intelligence algorithm can be used to estimate the parameter of a multimodal cost function. If it's unimodal, this LMS is fine. It is gradient method is best that gives the actual value. But if it is a multimodal cost function, many minima or many maxima, there is one global but multiple minima and maxima available, then smart intelligence algorithm should be used. Otherwise, there may be trapped into the local minima. Your answer is incorrect. Okay, this kind of concept maybe you have already discussed or going to discuss: local minima, global minima, multimodal functions. Okay. So now thing is, this is the desired data which is come up from the feed forward and feedback path. So there are coefficient to be estimated, that is feedback coefficient and feed forward coefficient A and B. There are n number of A and m plus 1 number of B coefficient to be measured. Okay. And in some input data are given to you. So what I said, this IR system, when we want to measure their parameter, it is a multimodal. I said it is a multimodal error square surface. So problem is the proper initialization required, otherwise you cannot get it. In literature, lot of swarm intelligence algorithm has been used to estimate the IR system parameter. You can search and you can Google later also. But I want to use this small intelligence algorithm in wireless sensor network, that too in a distributed scenario. Okay. So the diffusion small PSO has been used to estimate the parameter of IR system in a cooperative scenario. How it is will be? See this scenario, what I am talking to you. We may know or going to know the PSO algorithm, particle swarm optimization. It's the simplest optimization algorithm developed by some people in 1996, long back, 20 years back. Okay. So there are different terminology has been used. First of all, the particle, that means the agent which are going to estimate your parameters. Multi-agent problem, there are many particles are there. So everyone is trying to get the solution. So at each sensor node, you have to run the particles optimization algorithm, the same algorithm. I said the number of parameters to be estimated is m number of, it's an n number of A and B number of m plus 1 number of B to be estimated. So dimension is m plus n plus 1. This is dimension of your problem. Then the particles optimization involved with, I said the P best and G best. There are velocity, each one having its own solution. The personal best solution is the P best. So in a group, swarm means a group of this particles. In group, which one is the best, known as global best. Yeah, G stands for global. Global means in a particular iteration, among all the particles, which one has been the best solution? That one is the global. But going through a particular iteration, what level is the personal best is one particular agent's best is the personal best. For example, in a class, particular standard, a particular subject, one particular student is the topper. So see that student is the global best. But particular, see, if you go for one standard to another standard, a new topper may comes, then that will be the new topper will be the global best. But if you compare with the present standard and the previous standard, your mark may be increase or decrease. Accordingly, you can decide which one is the best. Last standard, you are the best solution, best grade or mark, and current you have best. So you have to choose one of them is the best. That is the personal best. Global best and personal best is there. These are the solution, means for these values, your cost function will be either minima or maxima, depends upon the type of problems you are following. Usually we follow the minimization problem. If it is maximization, make it minus of that and can make it minimization problem. So the personal best means this is the parameter. If you put in the cost function, that gives you best solution. So global means among all this best. So each iteration you have to change your position, means your solution to be changed incremental way. So that changes can be done with the velocity, like you are flying from one place to another place or moving from one place to another place. So that increment is known as the velocity. The velocity depends upon all these parameters. It is weighted on the previous velocity, and the difference between the personal best with the present changes. Like this, it happens. New position will be like this, the old position plus velocity. Okay. So there are some different kind of this PSO has been developed. Weighted PSO, adaptive PSO, quantum PSO, lot of PSO has been developed. We can use any one of them. So this is the simplest PSO algorithm I'm talking about. Okay. So in this case, my solution is a set of A and B that to be estimated. And initially, you need randomly do that. So once all the sensor nodes, they have their own global best. They share themselves, and global best can be updated. In the distributed approach, the global best has been updated. In that iteration, we can say this is the best one. Okay, diffusion best. But the question is, when you apply it to estimate IR system parameter, I said already there are n number of A and m plus 1 number of B to be estimated. K stands for node index, J stands for it's index of the particle, jth particle, kth node and jth particle, phi jk I have written. What should be the cost function? Cost function, I said it should be the error square only. What is error? Error is the actual value minus the value what we estimated. If you put the parameter, this value phi, into the cost system, this equation, I have written this equation, then we get y, this y. This AK, BK was parameter to be estimated. So if you put any value here, you can get y, but I supposed to get d, and this difference should be reduced. That is the procedure to follow. This error should be reduced. So while training, it is not blind training. It is somehow we know what should be my desired, where I am moving while optimizing the parameters. So then you can find out what should be the value of A and B. Okay. So usually in this approach, the advantage here, hardly we need less number of data, maybe 50 or 20 number of data is sufficient. So in each iteration, same data can be used to estimate the values. That is the advantage. So if you look the simulation results, we can compare. I said LMS is the best one if there is no multimodal function. And the corresponding hardwares are available if you want to realize in the real time. Whereas the PSO more computation required, but it has own advantage. I'm not denying that. Yeah, but if you want to get something, means you have to pay for that, like that. So you compare these parameters. So this is the methodology of any work. If you want to do, we have to compare with the existing and literature, and then you can say your is good. Okay. So that's the method we followed here. So you have to also repeat the experiments in all our Monte Carlo based experiment. So repeat and average should be plotted. Here 500 experiment we have done and average has been plotted. These are the example, different kind of IR systems it is given in the literature. The numerator, what parameter 1.25 minus 0.2, these are B, and the denominator 0.3 and 0.4, these are the A parameter. So the second order system means I have to go up to this -2. So that's the second order system. There are 2A and 2B values are there. Initially, see, in simulation, you know this, but I want to estimate without knowing. I assume this is parameter and does not know, but system output I know, and I want to estimate these values. Okay. Similarly, third order system means it goes to third order. So denominator parameters are A and the numerator parameters are B. So two systems has been compared, incremental and diffusion method. I said incremental means node by node, and diffusion means all the nodes set together. So if you look, diffusion method giving the better performance. So you have to approach in your distributed approach, better you follow diffusion approach. Now you compare with the PSO, diffusion PSO. So good, you cannot imagine. You see this green and this blue line. These are comes because of through the PSO. So the iteration wise, after 200 iterations, around 300, it may like more iterations, but the steady state value is too good compared to this LMS and non-cooperative LMS algorithm. The cooperations improves the performance, along with if you incorporate the swarm intelligence algorithm, then the performance further improves. It happened to all the kind of systems. Okay, so here all the values has been given, and you can see the actual parameters are 0.05. But if you measure in case of PS algorithm, it is 0.051 or 0.0504. Whereas in case of this LMS algorithm is 0.2381. Yeah? You see the first row here, it shows how much accurate your swarm intelligence algorithms are compared to your gradient based, the least mean square algorithms. Okay, so that is the advantage of swarm intelligence algorithm. You are always welcome, but first to define the problem here you are applying, and conventional methods fails to get the parameter properly. Okay, that is should be taken care. The second comparison, when you are doing this kind of operation, some parameter you are estimating, there are other two performance parameters can be used to comparison purpose. One is the average percentage of deviation, actual parameter, estimated parameter, so much it deviated from each other in percentage. Similarly, the sum of error square, difference square, you can add it up. So these parameters also you can see, this value should be very, very less. And you will see in our proposed swarm intelligence algorithm that to diffusion scenario, giving best performance. Whereas the LMS, diffusion LMS, it is more than 100, but you can get very near to 1 in case of proposed algorithm. So swarm intelligence algorithm is one of the best solution in this scenario that I want to say. Friends, we have estimated this IR system parameter by using diffusion PS algorithm. Two variation of PS has been used. One is weighted and the adaptive PSO. In weighted means, the past voltage has been weighted with W. The W value is going to decrease from 0.9 to 0.4 with iteration, and with minimum value you can use. Adaptive means rank based, so you can search and you can get it a lot of literature here. Then the simulus results are more interesting, and diffusion based PS giving the best performance. Okay, that is the things, one applications I have discussed here. The next applications, it is touches my application. No, I'm working on this basically. Source localization. The three methods are available, friends. Time delay of variable, direction of variable, and received signal strength. Based on this, we can localize your source. Especially the current standard of wireless communications beyond 5G or 6G, what you are taking. Localizing your source is must, because you need a complete pinpointed beam to transmit your data. So if you measure the location based on the received signal strength, it is very noisy, so we cannot have the accurate prediction. This time delay of variable, you need very good synchronization among the sensor node and sensor network. The major drawback is that very difficult to make them synchronization. That's why you are following the source localization using direction of variable estimation, so that the accuracy will be improved when there's some problem in the synchronization. Okay, that is the so we are following DO estimation method to localize the source. Different scenarios you may have in your problem. First is the locations. Your mobile phone, so you are localizing a particular mobile phone with respect to your base station. There are multiple mobile phones are there in particular locations. And what to do? Some mobile phones may be nearer to your base station, some little far away from the base station. If the sensor node is nearer to a base station, then you have to measure the range as well as at which angle it is present with respect to x-axis. So this is known as DO estimation, direction of variable. Range, both should be measured. But if it is far field, little away from it, we are assuming the distance is infinite, and we are measuring only the angle of that. Sometimes we have to measure multiple sources together at a time and mix also maybe happen. Some sources are near field and some sources are far field. The best example is localizing the mobile phones. We can localize without GPS. GPS is one kind of resources you need to localize, but it has consumed a lot of energy. If you switch on your location, you know how much energy the battery will be used. That okay. There are other technology also available. Now, second problem in this scenario, localization is the non-coherent and coherent signal. Most of the algorithms, they assume that coherent signals are non-coherent, they're not related at all. But in case of multipath environment, when we start particular locations, although you are unable to see the base station, you are receiving the signal. How it is feasible? This signal is electromagnetic signal travel as like light, straight line, but we are getting the signal. So it's reflected signal. So lot of reflected signal coming to you, and that known as coherent signal. All the reflected signals, the same signal, different attenuation, different phase difference, that is known as coherent signal. This is the scenario it is happening. We have to take care of that. Algorithms are available for non-coherent, but if it is coherent, it is a problem. But coherent is the real challenge, the real scenario. Similarly, if you talk about the sensor network, you are always trying to work essentially IoT, less data. IoT, the measure data. You want to estimate with the minimum data, maybe single data or multiple data, but minimum data to be used algorithm. Okay, that is the different challenges and the scenario it need to be done. So this is data model. If you are really want to interest to work, then only you can go through it. Your models also, you have to model the data, all the sensor data to be modeled here. So y equal to this response matrix. It depends upon the array number of source and their geometry. This source signal S and noise always there. So we'll have a matrix of data like this. So vector will get it y1, y2 to yn. If n number of sensors are there, this number of data will get a particular instant. So if you want to observe more instant, more sample value you can take, and that gives you the matrix. Okay. Now we have the data, why you have received. First of all, before applying a cost function, we should define a cost, before applying the smart intelligence algorithm, SI algorithm, we need to define its cost function. The cost function should be a function of your, the parameter with given data. So if theta changes, this F will be changed. R changes, F will change. R is the range of source from the center of base station, and theta is the angle of the source. So the cost function need to be developed first. Then this cost function, since smart intelligence means it is a population based, multi-agent based. So S number of population size you define. Each one to compute this cost function with respect to their location, their values. You choose the best one, and the best individual you can estimate it. This is the process of any kind of smart intelligence algorithm. We also followed that. There are not like that, no methods available, only the smart intelligence solution. No. Still, in hardware, people say in the real time, people use music algorithm, multiple signal classification algorithm. Because it is computationally inexpensive. We know that if there are 30 or 40 number of swarm, and each one having the computing this cost function, and then comparing their own with the others. So a lot of computations involved here. So, but the problem is in this music, it will fail when it is coherent, and the signals are coherent. Similarly, if you look, this maximum likelihood cost function, ML, maximum likelihood cost function is the statistically best cost function. That is cost function is multimodal. We cannot evaluate them directly. We should need a smart intelligence algorithm. This cost function work for coherent, non-coherent, low SNR also. very low signal strength, it will work. So we'll use ML technique. If you're really interested, you can go for compressive sensing method. There also you can use smart intelligence algorithm. We also use some correlation-based and Fibonacci-based cost functions. We have also developed some cost function. Okay, I'm not going to detail about this music algorithm. So this is my cost function. It is there in literature. No need to worry about the cost function, what is given, what can be used in this scenario. Let's say I want to localize my far field, only angle to be required. And these expressions are there, these variables. It is error response matrix. This is the signal, and this is the noise coverage matrix. We assume this Gaussian kind of noise, and it is uncorrelated noise. So this simplest cost functions are there, so we can get back, no problem. Okay, cost function is there, so I have to work on this. Now, if we have the cost function, I can go for different kind of small intelligence algorithm. I said since beginning, my likelihood function is a multi-dimensional as well as multimodal. Because why it is multi-dimensional? Sometimes you have to measure range and angle. Sometimes you have to measure different sources together, different angles together. So it is a multimodal. Sorry, multi-dimensional. And multimodal means if you plot the cost function, it looks there are many minima and maximums are available. Okay. So the conventional method fail here. You need a proper initialization. That's why you are going for smart intelligence algorithm. So only function evaluation required, no gradient, no global exploration. Sorry, it can be happen. No gradient is required. Centralized distributed approach. Since beginning, I introduced it should be a centralized and distributed both way. Same piece algorithm can be used. My solution is here the set of angles. That means angle of arrival of different sources. There P based, G based, same equations here I have written. So you have to use diffusion particle optimization means again this should be diffuse. So any algorithm when we have used, you have to also measure the performance of that algorithm, how good or how accurate it is, and then computational complexity, both should be analyzed. So if you're going for more accurate means you have to pay more, that's no doubt at all. So there are two performance matrices here I have taken. One is the mean square error. So what is actual angle of arrival and what is estimated. There difference square and average it. That's it. Then second one is the probability of resolution. Friends, that is interesting. If there are two sources very close to each other, the algorithm may not be recognized there are two individual sources. They may say that it is one source. So what should be my minimum distance between two sources so that I can recognize there are two individual sources. So the probability of resolution is that. So the probability of having two sources is there two sources only or one sources. If it is considered one source, gone case. So the completely wrong thing. It is two sources. That what is the probability that can be? So we can reduce the resolution basically. Think about this example. There are some sensor nodes are here, having 16 nodes, and 20 number of data points are observed at each sensor nodes. There are two sources at angles 130 and 138 degree directions. So they are incidenting on this array, sensor array. So all this data can be, think this sensor one is a centralized processor. The central one received all the data and estimated the angle. So this music I said, still it is a well analyzed algorithm, but it has not that good performance as the PSO. There is a theoretical benchmark known as Cramer-Rao lower bound. So you are whenever there is a likelihood method, you can have this theoretical benchmark, lowest bound, the Cramer-Rao lower bound. Rao is our Indian mathematician and Cramer someone else. So they should approach to this bound. You cannot go below. Okay. So this should be like that. and MIGIC is not having the good performance, though although it is used in the real time. So you are always looking for smart intelligence algorithm. Many algorithm has been used, they're not PSO. We can use any kind of algorithm because cost function is with you. Okay. Similarly, probable resolution also at -5 dB, you can resolve the two sources, whereas MIGIC is around +5 dB. So there is a 10 dB improvement in the algorithm. This is one likelihood function. You can use any kind of small intelligence algorithm. Currently, a lot of different small intelligence algorithm is available in literature. You can apply them and you can have different, you can say, the performance. You can improve the performance. Okay? Improve performance, you need less number of iterations, and also it should approach to this theoretical bound at less SNR. Less SNR means you can have lower power of transmission, so that still we can estimate the locations. Once you estimate location, then you can have targeted transmission. You know, now people are talking about reflected intelligence circuits, RIS. So there also we need to localize your sources. Second, I said, you know, snapshot means nothing but it is the sample value at each sensor node. This cost function we have developed, this correlation base, YKF, some estimated you can predict, and this is the conjugate of Y, complex conjugate. Y is the receipt vector, and total norm of Y and YKF can be done, and this 1 minus this should be minimized. So in case of coherent sources, that two near field, both range and angle can be determined. Where MLE is fail completely, the maximum likelihood estimate algorithm fail, and this cost function algorithm is giving better accuracy. If you look, this is for, you know, RMSE degree. This is for RMSE of this range when we estimate for near field sources. Both the cases, your blue line, that this correlation cost function is giving better the minimum. So we are applied this. Similarly, no, this is for probable resolution. In MLE, we are unable to achieve this probable resolution 1 at all, whereas this cost function approaching this. So this is the cost function used, but you have used PSO only to simulate these things. Okay. Fibonacci norm has been also used. If you use single snapshot, what is the problem? Sometimes some sensor may be malfunctioning. All of a sudden, out of, let's say, 8 sensor array has been used, one sensor has malfunction, but you are unable to know this. You are unaware of that. So what will happen? That particular sensor data will be completely different from other observations. This is known as outliers. All right. It is outlier kind of thing. So when this kind of outliers is present, this method fails. So we cannot, you know, estimate the thing. So it is not robust to malfunctioning of the sensor node. Somehow the MLE is, although its performance is not at good at all, but it robust to this kind of function. But this complex correlation fitness function, this cost function is not that much of a robust. We have used autoencoder here. LSTM also used in this case, but not complexity increases. Why you should go? But then residual fitting error matrix. So you have used instead of one snapshot, you can keep multiple snapshot. There you can find out Frobenius norm. This is basically, it is a Frobenius norm. Different type of L1 norm, L2 norm, Frobenius norm was there. So you have computed and try to measure these things. You look, this red line is benchmark, and these are the different optimization algorithms has been used. PSO, and this well optimization algorithm, WOA, and the gravitational optimization algorithm. So all this kind of algorithm has been used. You have seen that this well optimization giving the better performance compared to this W and PSO. You see. Okay, not so we have also used different optimization techniques, GW, gravitational wave search, and other algorithm. All right. In all the cases, the case A is this cost function. This is for r theta, and D is for degree. This is for lambda. This is lambda. This is for the lambda is given, so it is like that. And C is for degree. Then it's a near field source. Basically, they are near field only. And D is the cost function we plotted. These are the cost function A and D, and these are the RMSE values of the estimation in case of distance and degree, this angle. Okay, so yeah, all the cases what we have found, your WA web well optimization algorithm is giving some better performance rather than your gravitational wave search and other algorithm. Okay, so all three different algorithms also we have compared in this particular problem. Friends, this is centralized one. Now centralized means this approach, what I said, all the sensor node transmitting data to the one particular sensor node are known as base station. But why centralized? Why not distributed approach can be applied here? So here also distributed approach has been applied. What we have done, each sensor node along with its neighbor can consider as a sub-array. So as many number of sensor nodes are there, that many number of sub-array can be used, but they're overlapping. Not necessarily that individual sub-array are there. There are overlapping sub-array available. So now in this sub-array, this is one sensor node along with the neighbors. It has been act as a small array. Similarly, another sensor node along with this neighbor, it has another sensor array. So there are different sensor array. They are collecting the data at this point, and they can estimate the angle of arrival independently, not independently. They have to cooperate themselves. Independently, they do, then performance is very less because we are reducing the array size. When you reduce the array size, the information gathering is reduced, and that can have less performance. But if they do cooperatively with others, definitely their performance is as good as the done with together centralized method. Centralized disadvantage is that data communication is too high, so I try to avoid it. So as many number of communication reduced, that is the good for your algorithm and the network as well. It's energy efficient. Okay. So what we can do here, like this, we can do. So here, as many number of sensor node, I said that many number of sensor array, and each sensor array now run this PSO algorithm, particle sort optimization algorithm. Their global best has been set and diffused. Like diffuse means they have to multiply some constant. This constant known as metropolis weight, and the sum of this metropolis weight will be 1, and this one can be used as the previous global estimated. In this equation, particular iteration, what will happen? This global estimation value, either you can use it all, I can use the diffused one. So here, in case of diffused PSO, remaining are as it is, only this one will be used as the diffused one. So you can share the information of the neighbors to the neighbors and can receive the information from the neighbors. That is the advantage. So we can adapt with local data also as well as the global data. Okay. So if you look this network, there are 16 sensor nodes and the 16 arrays has been developed. This sensor node 1 is having the array with 2, 5, 8, 11, 13, and 16. This whole group is one sensor array. So at sensor node 6, if you look here, then it produces a sensor array with 4, 5, 8, and 7. So this will become sensor array with this. 5 also form another array. So each individual sensor node form an individual array and estimate the angle. Cost function remains at the maximum likely cost function only. So in this example, this is my network topology, and the two sources at 150 and 150 degree are coming to the source. 20 snapshots has been used for PSO, whereas 2000 has been used for the music algorithm. Otherwise, they cannot give a better performance, a comparable performance. So need more number of data. So you have to wait long time if you apply the music. Whereas PSO start with less no data. That means also required a little more time because of more computations, but no need to wait for data. Now computations is little easy. So we have a computation efficient problem. So this graph you may not get a lot, but let me tell you. Again, I said this is theoretical bound, the lowest one. If you consume the whole network is sensor array and estimate the locations. This one is sensor node 1 without any operations. These are the lower bound. Okay. You see, the global one is approaching this color, this one, the global PSO-ML data. And the blue one is with cooperations. So it try to achieve global, but may not be. So we are improving this cooperation, the performance, and we are trying to get this global one, but not happening because of not overlapping, because of overlapping sensors and the mathematical problem. Okay. Similarly, the peer performance also improved like anything. You can have the resolution, resolve the sensor lower SNR. That is the advantage, whereas other algorithm fail to it. What to do? Why should I have as many number of sensor node, that many of sensor array? Why not? I can divide into a clusters. And in computer engineering, the clustering is one of the best approach we can say. So we have divided the whole sensor network into different predefined cluster, but the cluster can be optimized also. I use K-means clustering only. Very simplest clustering algorithm. You can use different clustering algorithm as per the locations and as per the cost function. So the whole sensor network with 24 sensor node try to divide into 3 clusters, each nearly equal to 8 sensor node. Each individual cluster now estimate the angle of arrival with cooperation with other clusters. There will be a cluster head we can choose, and you choose the cluster head in such a way that their distance will be less. In this case, 10, 14, and 24. If I use, then I can have very good connectivity instead of using some other sensor node here. So cluster head also you can choose wisely, so communication may be reduced. So in this scenario, since there is no overlapping arrays, so performance improves a lot. At the same time, computation reduced too much. Instead of 24 sensor array, I use hardly 3. So computation also reduces. That is the advantage. And I have not optimized the cluster. We can have optimized clusters. You see, this much of advantage has been done. I know very close to now the global. If you use the clustering approach, communication reduces too much, and also accuracy improves. Okay, that is the advantage. Similarly, this probability resolution, I can resolve the sources at minus 7 dB SNR. Very good approach this is. Okay, whereas other algorithms need positive SNR. So very weak signals I can recognize. This is the clustering approach. We can also follow this kind of approaches. This is the last one. Let me briefly tell you what exactly this is a recent work. Friends, swarm intelligence algorithm. What is the problem? If you run time to time, they may not give always same result. Am I right? There may be in the vicinity of the global optima. So Z score, T score, many scores has been validated. in some application, for example, we are using this application, the drone, the missile you are firing, and you are targeting a particular locations. At that time, we need very, very accurate angle of arrival at this location. So in that case, you cannot apply the swarm intelligence algorithm always, because the small changes in that estimation algorithm also is a problem. But I cannot apply this mathematical, the analytical method also, because it has its own disadvantage, multimodal function. So I have to hybridize this. What to do? I use initially the swarm intelligence algorithm so that I can get the region where the solution lies, then apply the mathematical analytical method that can give you exact solution. So if you run the analytical method, always give the same solution. It will give the exact one, exact. There is no difference. So here we have applied that kind of hybridized algorithm. Not hybridized means so swarm and other hybrid. This swarm intelligence used for initialization. This mathematical analytical method used to estimate the angle, improve the accuracy. Then optimal DOI has been estimated. That too in different scenario, like coherent signal present or near field, far field present, like this scenario has been applied. You see, you can refer to this paper for more detail. Up to 70 iterations we have applied swarm intelligence algorithm. Then all of a sudden this Nelder-Mead, the simplest mathematical approach to get the solution, has been applied. This one is the distributed Cramér-Lower bound we have also derived. And we have different cooperation methodology has been there. The coefficient what used to diffuse has been also different, whatever may be. But this one, this gravitational wave source optimized algorithm giving so good result. You see, it is approaching to the theoretical bound around 100 iterations. That's good, and all other algorithm fails. That is the advantage of hybridization. Okay, there are 3 sources also been used here. At a time we can estimate 3 sources, not so the RMSE has been calculated. That's why probability resolution not has been calculated. Okay, this is at node 1, and this is the average of all the nodes. If you do that, still this approach is giving, hybridized approach is giving the best performance. So you can apply this hybridized approach when we need accurate solution in any optimization problem. Okay. Let me conclude. I think timing is also. Friends, I don't know how much I conveyed to you, but I try to convey 2 things here. If there is a sensor network, lot of applications we know. If nodes are distributed, then let us have a cooperative estimation or cooperative optimization algorithm. Individual node have its computational capability now. They can compute like your Raspberry Pi. It can be used as a mini computer. For example, you have deployed a sensor node as a Raspberry Pi at different locations. So Raspberry Pi can do that like that. So if there are multiple sensor nodes are there, they are interconnected. Why should collect all the raw data at the central processor or the user? Why not they can have some raw estimation and give to you? So you can reduce the amount of communication and delay. If you reduce the amount of communication means energy will be reduced, delay also reduced. That is the one thing you think about that. whenever there is a distributed approach, it is always good. So I also explain you how we can incorporate them. Incremental way means you need a cycle. Diffusion means a node take the information from all the neighbors and diffuse them, use as a previous estimated values and update it. Incremental diffusion, that has been said. One example has been discussed at the first, the estimation of IR system parameter. If you model a system, in digital signal processing, a system is modeled either by FIR type or IR type. Finite impulse response or infinite impulse response. One kind is not required a feedback, another kind need a feedback. Lot of applications are there, they need a feedback path. If there is a feedback path, then you can model the system as a IR system only. In IR system, the advantage is having less number of coefficients, you can model the real-time system. But I don't know what is the parameter I model. And sometimes maybe the malfunction happen, the parameter maybe changes. I want to estimate them. So if I estimate the IR system parameter using the conventional methods are available, that not gives the accurate, and that also depends upon the kind of IR system. It is very sensitive, essentially. The stability is a problem. So people says when you use this small intelligence algorithm long back, not after sensor network comes. Before also it has been used. But in distributed scenario, how can you apply the swarm intelligence algorithms to estimate the parameter of a feedback system? I have discussed, and I assure that your distributed approach giving better solution compared to the conventional. That is the message I want to say. Second, sorry, anyone? Let me conclude, then I will give the scope to ask questions. Then next, what applications I discussed here? The second application is the source localization. This is also important task of our sensor network. Source can be localized. The cost function is available to you, the likelihood function. That cost function itself is a multimodal. So very difficult to use the analytical method to get the solution. The solution that, they must use smart intelligence. So I use PSO. That too in the distributed scenario also we can apply them. Different kind of intelligence algorithm can be applied, compare them, and you see which one is good. Less iterations I need, and I should get a better performance, accuracy. Okay, so that is another angle I have discussed. Then last I introduced the hybrid method. That is also required sometimes when you need a good estimation. Hybridize your smart intelligence algorithm. It is used to initialization because multi-agents, they may search the region where the solution is. We run the algorithm, smart intelligence up to certain iterations. When I ensure that my solution lies nearby, apply that, use the initialization and apply the analytical method. It gives you exact value. And analytical method also you can reduce the computations. If I further use this smart intelligence algorithm, more iteration, more computation, analytical method, only one agent, and you can reduce the computations also. So this is the things I try to convey you. Now, if anyone having any queries, please you ask. If I am able to answer, it's fine. Otherwise, we can have the offline discussion also. Hello. Someone raise the hand. Please go ahead with your question. If you have anything, any question. Hello.
Participants, please ask any questions.
Madam, it is for 1.5 hours, am I right? Or can I continue? No, no. This is for 1.5 hours. It's per the schedule. Okay.
Sir, you can.
No, it's fine. It's
Sir, you
fine.
can
No.
Sir,
I
you
already
continue up to 4.
No, I concluded. I concluded. And if any question, I am here. No problem. So I
Okay,
thought
sir, okay.
maybe it's good. Good. So participants, if you are students, it is a very good opportunity. You can start work on the distributed approach. You can take any new algorithm in your problem and think how to model them in distributed scenario, apply. So that will help you to understand the algorithm, and it also helps research fraternity. No, your contribution will be well appreciated. So two different problems has been discussed here. Parameter estimation. Second one is the source localizations. So it is not limited to PSO or gravitational search algorithm. What we have done every month, every times we have a lot of new algorithms improved a lot. We can use them. And if you are really interested, my email ID is there, and you can contact with us. We are definitely help you. My teams are here. PA students are working, so it will help you, but not in the algorithm side. I don't have any idea, anything related to algorithm. I'm talking about the application only. Algorithm is easy to understand, or it is not my talk. My talk today is on the applications. So we have not developed any new algorithm. I have used what are the algorithms available in the literature. The cost function also available. Somewhere some new cost function we have proposed. So we may also propose a new cost functions, but you should understand what is your problem and how to mathematically model them. Then develop your own cost function, apply any one of the algorithm. That is the best contribution, we can say. Instead of applying somewhere PSU is applied, I want to apply gravitational search, I may get better performance. It is for learning purpose, but the contribution may not be that much appreciated if you have your own cost function and apply some swarm intelligence algorithm. All right. So don't try to carry 2 kilo potato using a elephant. You know, if you use swarm intelligence algorithm, use it. No one will be interested to read it. So you have to justify why we need to use your smart intelligence algorithm or machine learning. I have not talked nothing about machine learning approach, but first is your problem statement. Second is the justification why you're applying the smart intelligence algorithm. Third is your performance, how your algorithm is good with respect to some existing approaches available in the recent literatures. That no one can deny. Okay, so my best wishes to all of you. If you have any queries, still I am here, no problem. You can ask where you are unable to get my flow. It is very hard to keep your concentrate after the lunch. I may try my level best. It's over to you, madam. If you have any questions, I'm happy to answer. So otherwise, it's over to you.
Thank you, sir. Thank you for your valuable knowledge and for enlightening our. Thank you, sir. I request all the participants to join for tomorrow's session at 9:30. For today, all the 3 sessions are completed, and we will share the feedback link soon in the WhatsApp group. And we have shared the attendance link in the WhatsApp group. From tomorrow onwards, for every session, we will share the attendance sheet and feedback. Thank you. We will join tomorrow morning at 9:30 a.m. Same link will be followed for all the. Sir?
Thank you.
Same
Thank you
link
all.
will be
Let me leave.
followed for. Okay, sir. Thank you, sir.
Thank you, sir. Thank
Hello,
you.
ma'am. Hello. Ma'am, can you hear me?
Hello. Yes.
Hello, ma'am, can you hear me? Ma'am,
Yes. Yes.
when we are
ma'am.
filling the form, there is salutation in which there are only 3 things, Dr., Mr. and Mrs. Can you please put Miss in there?
Okay. Okay. Sure, ma'am. We will definitely
Okay.
include that one.
And what we have to put in ID?
IDs are already shared in the chat, ma'am. Again, that same thing is
Okay.
also shared in the WhatsApp group. IDs are given
Okay.
there.
Okay. So that ID we have to put?
Yes, yes, ma'am. That helps us to give
Okay.
the attendance.
Okay.
Thank you for all the
Thank you so
participants
much.
for being
Ma'am,
very supportive and
Ma'am, I'm
cooperative.
unable to see the feedback link. Have you shared the feedback, ma'am?
No, sir. We will share soon. We didn't share the feedback link, sir. We will share
Attendance?
already. Sir, already shared, sir. You can once check in WhatsApp group, sir. Attendance is also shared, sir.
WhatsApp group, it's not there. You shared
Sir,
in the
are you
morning,
there
ma'am?
in the what? No, sir. Can you share?
It is not there. Atal Web
So,
DB.
so 1 second, sir.
Yeah. Okay. Okay, madam. I could see now. Yes.
Okay, sir. Did you find it, sir?
Feedback session is there. Attend. Okay.
Can you please
Attendance
share
is
the
also.
Madam, if you can share it to
Ma'am?
email, that is good, ma'am. Because I will be accessing our desktops.
Ma'am, can you
Sir,
please
from
share the
tomorrow, if
attendance
you,
also?
we'll keep it in the chat also, sir.
Madam, chart it is disabled.
Chat is disabled,
Enable
sir.
Yes,
Okay,
ma'am.
okay. We'll enable the chat, sir.
Okay, ma'am. Okay, ma'am. Okay, thank you.
Ma'am, somebody is asking.
Yeah, ma'am, can you please share the attendance also?
We have already shared the link in WhatsApp group, ma'am.
But
Once
I
check it out again.
haven't received the link, ma'am.
Ma'am, are you there in a WhatsApp group?
Yes, ma'am, I'm there, but
Okay,
I
again
haven't
we'll post it,
the
ma'am.
link.
Again we will post the feedback
Okay.
link and attendance link.
Thank you, ma'am.
Thank you all participants. Thank you.